Hello everybody and welcome to see our video. My name is Ilkka Jormanainen and I'm working as a senior researcher at the School of Computing, the University of Eastern Finland. Today I'm going to present a paper titled Interacting by Drawing, Introducing Machine Learning Ideas to Children at a K-9 Science Fair. This work is co-authored by me, Tapani, Toivonen, Matti, Tedre, Radu, Mariescu-Istodor, Teemu, Valtonen, Henriikka, Vartiainen and Juho, Kahila. We all are coming from the University of Eastern Finland, except of Radu, who is coming from Karelia University of Applied Sciences. Let me start by defining what machine learning in K-9 or in more general K-12 level means. Nowadays, it is very essential to develop the school children understanding on how machine learning-based data-driven automation work requires different kind of skills and competencies that the traditional computational thinking teaching necessarily does not provide. To help teaching machine learning in school settings, there are plenty of low-floor, easily accessible tools and educational technology available, and they are quite good tools to teach in K-9 or K-12 classrooms as well. These tools usually are web-based, they are easy to access and easy to adopt into the teaching practices. While the tools are emerging, also research evolves, especially on how to use media-rich applications to teach machine learning in K-12. So, in this paper we are going to present a tool called Learn Machine Learning or Not Black Box. And we report in this article a case study where we use these tools to teach basic machine learning concepts such as image recognition, supervised learning, training data, model, feature, classifying, and accuracy for children from 5 years and older. On the right-hand side, you are seeing a user interface of the tool. On box A, there is the webcam feed which shows currently a picture of a giraffe. On box B, there is a black and white presentation of the same picture. As you can see, there is also a bounding box drawn around the object, giraffe in this case. This is one of the features that we are interested in when doing the image classification. On box C, you see two-dimensional plot showing aspect ratio and the fullness of the picture. These are the two properties that I use to map the image into a predefined class. As you can see on box D, there are a few already classified items that also appear on the two-dimensional plot on box C. Before we jump into the case study that we did at the science fair, let me leave you with my colleague Radu to explain how this Learn Machine Learning tool actually works.
Hi and welcome to NoBB, where we build apps without using any black box components and study all the parts that make them work. Today we're going to use the camera and build a web app that learns to recognize different objects. We'll first have to teach it things like this is a perch, this is a salmon, this is a giraffe, this is an elephant, this is a spruce, this is an oak, this is a pencil, this is a camera. Now, let's see if it can recognize the things. Yes, 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 yes. Ah, this is not a fish. What we can do now is tell it this is a spruce and just go on. How about if I draw something? Neat. It works.
So, back to the slides. The workshop design. The workshop and the case study was conducted at SciFest Joensuu, which is the largest science and technology fair in Finland. We managed to get about 150 participants into our machine learning workshop, where we asked the participants, kids and their parents, to draw animals and see if the tool would be able to recognize those drawings. In this case study, our main purpose is to report the children's interaction with the machine learning image recognition tool. So the main findings can be divided into 3 categories. First, those who came to the workshop in rush and just tried the tool out without getting any particular instructions got quite easily frustrated because the system didn't recognize the drawing. On the other hand, those who stayed longer in the workshop had a focus on trying to improve the drawing by adding some unique features of the animal. For example, they were eager to add spots on a giraffe if it was just an outline. And what is remarkable and what we notice is that those who failed at first and stayed then for a longer explanation did show a clear understanding of how the features of the drawing, that is aspect ratio and fullness, affect to the classification. What we learned from the workshop. There is, while the kids are working in this kind of tasks, a clear shift on locus of explanation from what oneself does to what the computer does, meaning that from explaining that what they have been drawing, over the time, the kids also start to understand what the computer does, and the explanations that they were providing for us changed clearly into this category. And this shift on locus of explanation is definitely one of the most important elements when we are developing children's sense for data agency. New and emerging aspects of computational thinking can be drawn also from the machine learning exercises and this kind of case studies. While the traditional computational thinking focuses on algorithmic thinking, problem breakdown, and so forth, we see and we argue that machine learning and the skills needed in machine learning form a new kind of computational thinking approach, so-called Computational Thinking 2.0. Thanks for the participating and seeing the video. You can reach us by email, and we are very happy to collaborate on any of these kind of topics.